Well, hello to everyone. My name is Javier Sanchez Gutierrez, and I'm going to talk about my final project, Make Solar Energy Economical. Well, the main objective of the present project is try to find a new and innovative way to make solar energy economical. One of the most promising ways to do so is the use of quantum dot technology. Well, as you can know, the theoretical efficiency is limited because of thermodynamic effects, and this is because the solar energies use semiconductor materials at between the valence band and the conductive band. There is a band gap. When an incoming photon is coming with an energy greater than that band gap, the excess of the energy is only producing heat, and that heat is not good for solar energy, for our solar cell. So we propose the quantum dot technology. What is a quantum dot? Quantum dot is a nanostructure with a semiconductor behavior, and because of its size, the properties differ from the larger particle properties. And what is the big difference is that we can control the band gap, controlling the size of the quantum dot. This is very important because this opens a lot of possibilities, and moreover, in quantum dot solar cells there is an effect called multiple exciton generation that, as the name says, it generates more than one exciton. An exciton is a whole electron hole pair that is producing when an incoming photon have more energy than the band gap. So this increases the efficiency, the multiple exciton generation. Well, but nowadays the quantum dots are not good enough because we don't have a lot of quantum dot solar cells around us. So what we propose here is to use a new material and a new process. Let's begin with the new material. We want to try to avoid typical materials used for this, the 3,5 compound, and we propose to use fullerenes. Fullerenes is a type of graphene. In fact, it's a graphene with an spherical shape, but it has almost the same properties. The difficult step here is to make that fullerene semiconductor, but it can be done. In fact, it has been done. So we can do it, and we can take advantage of the superconductivity because we can create even more number of average excitons produced. The other way is to try and reduce the cost. I think the first idea you think when you are trying to do something economical. We are trying to use the roll-to-roll technology. This is a technology used for flexible electronics that produce a very large amount of flexible electronics in a quick and cheap way. The thing is, we have to create a solution of quantum dots, and to do that, because of the nano size, we have to prevent these nanoparticles, these quantum dots, to aggregate, because as I said before, we have to control the band gap at the excess of heat generated through the size of the quantum dot. So we cannot allow them to aggregate because we are not controlling the band gap anymore or the heat produced. But we can do that through sonication or with additives. So with these two options, or the combination of both, we think we open a new path for economical solar energy. And I think that's all. So thank you very much for watching, and I hope you enjoyed the presentation. Thank you.